the previous video, we started off with the basics of object-oriented programming. We talked about encapsulation, which is one of the main distinguishing features or tenets of object-oriented programming. There are 3 tenets, and we'll cover all of them before everything's said and done here. To recap, encapsulation is the process of keeping the implementation details about an object private. We use the analogy of a car. All I have is a steering wheel, the brake, the accelerator, the signal, turn signal thingy. I told you I don't know anything about cars. And that's it. Everything else is under the hood. All I need are those simple interfaces to work with the car object. Same is true with object-oriented programming. We want to keep all of our implementation details under the hood. Okay, so in the previous video, we started off with the basics of methods and fields. We didn't really talk much about them. I want to start uncovering more information about both of those and even expand beyond that for the remainder of the day. At the outset of the video series, we said that methods, like the main method, for example, contained a block of code and it had a name. So it was a named block of code. When we created our own example in the previous video, we gave our methods accelerate and decelerate a name, and we gave them a block of code. Okay, same thing. We also said throughout the last 2 days that methods can optionally accept parameters and optionally return a value. So here, my methods accelerate and decelerate, they don't accept any parameters because I haven't defined any parameters in the parentheses, nor have I returned any values. The only thing I do is print out to the console window. This word void means that I'm not going to return a value back. And let me explain exactly what I mean by that. Let's change the accelerate and decelerate to return a value. We're going to return the current speed instead of just writing it out. So we'll comment out this line of code, and then we'll return speed. Okay? Same is true here. So now these methods are no longer void. They no longer return nothing. They return something. Now we can ignore what they return, but they do attempt to at least return us something, in this case, the speed, the current speed. So let's save this, and then let's rewrite our program to capture that. So in fact, what we're going to do is create a new int called myCurrentSpeed and set it equal to 0. And then we're going to set myCurrentSpeed equal to myCarAccelerate. Now we're going to slip that in there, so that we're going to console.writeLine myCurrentSpeed with, let's change this, myCurrentSpeed. And then we'll do it again. We'll just not use that until we get down here again. So I'm going to go myCurrentSpeed equals decelerate. Copy this line of code here again. There. All right, so you can see examples of both, of capturing the value that I expect to be returned from the accelerate method, and here I'm ignoring the values that will be returned by the accelerate method. This is similar to how readLine works. Remember, we used readLine for 2 purposes. One, to stop the execution of the program, but then we also used it to capture whatever the user typed into the keyboard. Same idea. Okay, so let's run the application now and see how this works. All right, so we see that the current speed starts out at 1, and then we skip a couple of accelerations and decelerations until we get to myCurrentSpeed 2. All right, if that doesn't make sense, set your breakpoint like we looked at in yesterday's videos and start stepping through things, and use the Step Into button this time on that toolbar, and you can see how it will call back into the methods. Okay. All right, so now what else do we need to talk about with regards to the methods that we have here? We can see we use this keyword return to return a value. Let's do one other thing. let's create a public string speed limit violation. All right, this is a little bit weak, admittedly. But I know cars like BMWs, they have this little thing that if you go too fast, you can set it to a certain speed and say, hey, if I get over 55 miles an hour, send me an alarm, okay, and tell me that I'm going too fast. So let's add that as a feature to the car class. And so we'll call speed limit violation, and we'll just do a quick check here. If speed is greater than, I don't know, 3 miles an hour, might be a little low, then return, else return, all right, too fast, you're okay. All right, so now let's call string message equals my car dot speed limit violation. There it is. Whoops, what am I doing? Okay, and now we want to do a console.write line with message. In fact, well, let's just leave it right there. Okay. All right, so at that point we were okay. Apparently we didn't go over 3 miles an hour. Let's speed up a little bit here. All right, so we're going too fast. All right, very good. Now typically what you want to do is avoid the scenario that I've demonstrated here. I did this on purpose. You don't want to use 2 return statements. Typically, this is just a recipe for disaster. It complicates your code. What you should do instead is only have 1 return message and usually put it at the very end of the method. So what I would probably prefer as a convention, it's not a requirement, it's just a best practice to do something like this. Message equals, and then we will set message equal to, and you're going to say, boy, that's a lot more typing. I thought you wanted to avoid typing so much. Yeah, that's true. We want to avoid typing unless it makes sense, unless there's some established best practice that says it's probably a good idea to do this. And this is probably how I would prefer to write this in the future. Let's run it again. Still works. Okay. So we just refactored the method that we created. All right, so far we're talking about creating methods. We're going to talk about this keyword public a little bit later. Not going to talk about accessibility modifiers just yet. Bear with me. We have to define the return value of our methods. If we don't expect there to be any return value, then we would use the word void. Okay. If we try to use the word void, but then use a return keyword, we're going to get an error. Since the method returns a void, a return keyword must not be followed by an object expression. Okay. Next up, defining parameters for our methods. Recall that it's completely optional whether we define a parameter or not. In this case, what I want to do is, instead of just assuming that speed will be incremented by 1 mile per hour, I want to allow our methods to accept a parameter that defines just how fast we want to increase our speed by. Okay, so here what we will do is type in the data type that we expect, and then an identifier, a variable that will be used throughout the body of the method to reference the value that was passed in by the user of our class. So in this case, we're going to set increased speed. So then we'll do a new operator that you didn't see yet, plus equals increased speed. And the plus equal sign means add this value to this variable. So whatever this current value of the variable is, keep it and add this to it. It's the equivalent of writing this. just a little shorthand, okay? And this is used all the time. All right, so we'll do the same thing with decelerate. Int decreased speed. And so we'll do speed minus equals decreased speed. All right, so now we're going to rerun our application. Well, what do we need to do? We need to, you can see we have a problem. We changed the method signature, and therefore we blew up all of our code in the program.cs, so we're going to need to modify that. So let's start typing in 3 here, and 5 here, and 6 here, and 2 there, and 1 there, and then, oh, we don't even have a decelerate in here, do we? Oh well. I guess we're, oh yeah, we do. Here we go. And we'll decelerate by 20. And so here we go. We're going to run our application now. Whoops, I think I decelerated a little bit too much. Perhaps this is a good issue to bring up later. We'll revisit that. Okay, so at any rate, so we've talked about defining parameters. Oh, also, if I needed to define multiple parameters, I could do it this way. How can I change up the ones that I've already got here? I know what we'll do. We'll put in string initial message, and then we're going to put in int speed limit, and I'm going to lowercase that, speed limit. Okay, so what we'll do is that, and then instead of hard coding this to 3, we'll use this identifier in the body of our method. So we're using this initial message to help format our string message that we return, and then we will use the speed limit to determine if our current speed is too fast. Notice how I defined multiple parameters. I used a comma to separate the first parameter definition from the second parameter definition. Okay. All right, so let's go back to our program.cs now. I know we're going to have that issue. I'll do warning, something like that as our initial message, just a silly example, right? And then we'll change this to 20, and I'm only going to be decelerating by 5 so that we can see this. Okay. So now let's run the application. All right, so you can see now we have changed up the return value of that speed limit violation method. You're okay, current speed is 12. All right, that makes sense because we set 20 as the speed limit violation. Let's accelerate this by 10 and see what happens. Too fast, current speed is 21. All right, so the changes that we made to our speed limit violation method seem to work just fine. All right, silly examples, I know, bear with me. We're just trying to illustrate the point about how to create a method, how to create methods that return values or are void methods that return no values, how to accept parameters into our methods, even multiple parameters like we demonstrated right here. One more thing before we leave this topic, a little terminology lesson. All right, so later on, and maybe as you're reading other material, you'll come across the word method header and the word method signature. There's a little nuance between the two. This entire definition here is the method header. A method signature only includes, here, let me just kind of copy this out and put it down here. It's not something that you'll ever see in code per se. Well, I take that back. You will actually see this in code, but not for quite some time. So that's the method signature. Signature includes only the data types. The whole header includes the data types and the names of the parameters. Okay, just a little tiny distinction. It'll be important, like, I don't know, several days from now when we get to that point. Just wanted to say it right now. Okay, so that's all I can say about methods for the moment. We'll probably tack on a few additional ideas over the next 2 or 3 days. So we'll see you in the next video, and we'll talk about fields, I think. Thank you.